All right, sirs and ma'am. So here's our video on day 2 of domain and range. I am going to put some things up here, and hopefully my camera and everything works out so you can see what we're doing. And we will walk through this right quick. Um, so, day 1 IE notes. Domain and range. Notation. So, example 1. This one really isn't even a function. Doesn't pass the line test. So let's say you got a point here at, we'll just call it 2, 1. And then you've got an infinitely positive domain here, right? And then your range does the same thing, but the range goes negative infinity to infinity. Or the domain was just infinity to infinity. Okay, so we're talking about an inequality here where it's doing this thing. Negative 2 less than or equal to x, which is less than infinity. You can't be equal to infinity because you can't get there, right? Okay. Your range all real numbers, or negative infinity is less than y is less than infinity, or just all reals. Okay. Y equals all reals. Set is just sticking it in fancy brackets, right? So x negative 2 less than or equal to x less than infinity. And for y, y equals all reals. You can just put that in there. Negative 2 to infinity on the interval notation for domain, range negative infinity to infinity, both with parentheses because you may not get there. Okay. Let's see. Look at what you're looking at here. All right. So, second example here. You might have an actual line, right? A line doesn't stop. You've got negative infinity on the upper left, and positive infinity, negative infinity on the bottom right. I'm just going to say x is all reals for domain. And for range, y equals all reals. Why write anything else, right? Set notation, go ahead and put your inequalities in there. Negative infinity less than x less than infinity. For y, negative infinity less than y less than positive infinity. And then for interval, negative infinity to infinity. We always start left to right on domain and bottom to top on range. So then we have a discrete example. Hold on, let me switch over and make sure you can see it. Okay. We got a discrete example. Negative 4, 2. Say you have something at negative 4, 2. There's a point. You got a point at negative 1, 1. Right? You got a point at 1, 2, 3, 0. A point at negative 1, negative 1. And 1, negative 3. Okay, so discrete set only. You can't do this with inequality or interval notation because, well, there's no connection. So for x equals, well, all the points where x is at, you got negative 4 over here, negative 1, 1, and 3. For y, you've got y equals negative 3, negative 1, 0, 1, and 2. Now notice there's more y's because 2 of the x's match up. Be the same if 2 of the x's match up and 1 of the y's, but you don't note something twice. Okay, if negative 1 occurs twice, you don't put it twice in the domain. It's at negative 1. Okay, it's at negative 1. I don't care that it's at negative 1 twice. You only list at negative 1 once. Okay, but you list the y's because they don't match up. All these numbers are separate individual numbers. You never list a number twice on a discrete set. Okay. Well, that's it for the video, and we'll talk in shop.